Hello. All right. Okay. We are going to do a quiz, but it's more just to get another quiz grade. It's not to try and make your life a disaster or anything. But I will answer any questions that you might have over those homework problems or any of the homework problems.
Just a quick question. On E, you're supposed to use a 2.718, right?
You can use it, or you can use your calculator. It has an E button also. So which one would you like me to talk about? Okay, so this one right here. All right. Yes? I'll just do it right here. So we're trying to solve for x, right? And I said at the end of class last time, it's probably still up here also. I said that in order to use that, come in with the log on each side, you first have to make it look like b to something. And it has to be the base by itself. So you need to get that e right here with the power x plus 1 by itself first. So we'll just do this like we would like a linear equation. We're isolating that, so we add 3 to both sides first. And so what you're left with is 5e raised to the x plus 1 equals 17 plus 3, which is 20. Now divide both sides by 5. Because that 5 in front is not being raised to a power. So it's important to understand when you have 5e to the x plus 1, the x plus 1 is only acting on the e. The 5 is a multiplication in front. All right? So your base is not 5, your base is e. The 5 is a scalar. Scalar is like a multiple. It's a multiple of that. So we come through and eliminate that 5 first by dividing. Hey, you even said that at the end of class last time. I listened to the video again, and you, at the very end, you're like, you'll divide by 5. And I said, yep, that's what you'll do. Yep. So, hey, there you go. Okay, so 5 divided by 5 is gone. Over here, we get 4 on the right-hand side. E to the x plus 1 equals 4. And now at this point, you can come in and try and wipe out the e. But to wipe out the e, you have to come in with the log that has base e. And which log has base e? The natural log, ln. Okay, so you'll come in with natural log on the left side. And whatever you do to the left side, you must do the right side, so natural log 4. 4. All right? Nope. Still got a ways to go here. Now, what happens on the left side? Natural log e is 1. Or there was a property. Let me go to my properties. Hold on. Yeah, they cancel each other out. It's this property right here. If you have natural log of e to something, right? Doesn't matter what's up there. Then the natural log and e kill each other off. That's why we do it, all right? Kill each other off, and that thing that was stuck up there is now dropped down, and it just is sitting there. So we're going to have on the left side here, the natural log and e kill each other off. We're left with just what was up there, x plus 1, right? Equals the right side, which is natural log 4. Now, natural log 4 is some number, so we get our calculator out. And we'll round, 2 decimal places. I think that's what I said in class last time. 1.386, so I'll do 1.339. Okay? So I have x plus 1 equals 1.39. And now to get x, what? Subtract 1. So when you subtract 1, you get x is equal to 0.39. Damn. Questions? E to the x equals 10? All right. Yes,
Do you know how to type what you just did on this document?
I do.
Could you tell me
I will in just a second. I will. What was it? E to the x equals 10? So you're trying to solve for x, right? So if your x is up in the exponent, which means you need to get it out of the exponent, to do that, you're going to have to come in with the log, right? And you need to have the base, which in this case, again, is e. You need to have that base by itself on one side of the equation with nothing else over there, which you have, right? You actually have that? So no subtracting, no dividing. I mean, we're ready to go with the log. Which log do we use? The ln again, because the natural log is the inverse of e. So natural log e to the x, whatever you do on the left, you must do on the right, right? Let me see your calculator. Your natural log key is right here. So you turn it on. And you can barely see this. All right, you just hit natural log and then 10, enter. That's it. Okay, so what do I get on the left side there? X, right? Everything cancels out. The x drops down. Right side, natural log 10, right? Now that's it. I mean, that's the answer, right? You could actually leave it as natural log 10, or you could get on your calculator and figure it out. Yes. Yes. It's possible.
if we get a lot of decimals, how many do you think?
2 decimal places. 3, 0. So this would round to 0, so 3, 0. It's oh wait, I don't know why I put negative. You were saying negative while I was writing. Sorry. I couldn't process those two things at one time, apparently. Yeah, number 2. This one right here. 4 to the 2 minus x equals 8. 4 to the 2 minus x equals 8. Okay. What I was going to see if you would accidentally do, I was hoping you wouldn't, is like try and divide by 4 or something. Okay, you can't do that, all right, because that 4 is not attached to the 2 minus x with multiplication. It's a power. So we have the power, that's what we're trying to get down. The base it's attached to is 4, right? Is that base by itself? Yes, right? There's nothing in front of it. There's nothing added or subtracted. So we're ready to come in with a log. Which log will we use? Log base 4. So I come in here, log base 4 of whatever was there on the left side. So 4 raised to the 2 minus x equals, now whatever I do on the left, I have to do on the right. Log base 4 of 8. Any questions on that? All right. Now, by design, the left side should all wipe out, right? The log base 4 and the 4 should wipe out, and the only thing left would be what? 2 minus x. Okay. Equals, now on the right side, yeah, that's the first thing I would look at when I look at this is to think about what log meant again. So I'd be saying to myself, right, I'd be thinking 4, right, that's the base, raised to what power is 8? And then I go, I don't know. I know 4 times 2 is 8, but that's not what I'm asking. 4 raised to what power is 8? Can't figure it out. So we had last class, the change of base formula. This turns into ln 8, or natural log 8, over natural log 4. So now I'm going to get on my calculator and do that. Natural log 8. I don't know, for some reason I can't remember where my natural log key is today. Natural log 4. I've got it. 1.5. You should get 1.5. So the right side becomes 1.5. The left side is 2 minus x. So I'm trying to solve for x, right? I could subtract 2 on both sides. That's fine. I'd have negative x. Subtracting 2, I should get negative 0.5. Then divide or multiply both sides by negative 1. And that'll basically just change the signs on both sides. So your answer is 0.5. That help? Okay, let's do this. Just take out a sheet of paper, put your name on it, and we're just going to do a quick quiz. I'm more doing this just to kind of help your grade, all right? See if we can bump it up a little bit. All right, and just do this. Put your name on it, put today's date, and put quiz. You don't need to put a number, just quiz. And I just want you to solve this one problem. 8 e to the 2 minus x plus 1 equals 17. All right, solve for x. And do your own work, please, today. Five minutes, that's all you get. All right, so the first thing you would do is make sure that you try and isolate this part, right? So subtract 1 on both sides, you get 8 e to the 2 minus x equals 16. Divide both sides by 8. You get e to the 2 minus x equals 2. Come in natural log both sides. That'll give you 2 minus x equals natural log 2. The natural log of 2, 0.693. So 2 minus x equals 0.69. I said 2 decimals? Okay. And then subtract 2 from both sides, right? So if I subtract 2, I get negative x equals negative 1.31. Then divide both sides by negative 1 or multiply by negative 1. X is 1.31. Okay, that's it. Ready? New stuff today. New stuff. All right, last class we talked about properties of logs, right? And I gave you some properties. Here's what they were. These were our first 3 properties of the logs, right? And now I'm going to continue today with more. And so the first property I put up here is going to be property number 4, all right? Okay? That's what we're doing. I just didn't want you to freak out when I say, property 4. More properties. Okay, property 4 says this. If you have a log of any base, and inside of it you have u times v. So u times v could be anything, just 2 things being multiplied together, all right? Then you are allowed to take that log, base b, and put just the u there, then plus log base b of the v. So let's discuss what just happened here. On the left side of this equation, you had how many logs? 1 log, right? So I'm going to put this under here. I have 1 log with multiplication inside of it, right? And what happened was, through this equation, through this property, it turns into how many logs? 2 logs added together, right? The u goes into one of the logs and the v goes into the other. All right? Now, I'm not here to explain why that's true, but that is a property of all logarithms. So this could hold for log base 10. This could hold for natural log. Anytime you have multiplication inside of a log, you can split it into 2 logs, okay? With addition. Would you like to see an example, or you want me to go to the next property and then show you examples at the end? I don't care. Next property? I'll do all the examples at the end. Log base b, so same thing, log base b, any log. If we have u divided by v inside instead of multiplied, what do you think that would become? What? Log base b u minus log base b v. So the multiplication that we had in the in the fourth property, if we had multiplication inside of a log, it turned into the addition of 2 logs, right? Fifth property says if you have division inside of a single log, you can split this into 2 logs and put subtraction between them. So I'll put that again underneath here. We have 1 log, right? We have division inside. Turns into 2 logs subtracted. All right. Sixth property. This one's an interesting one. Log base b of u raised to the n power. So what I have now is some log, right? Doesn't matter what the base is. I have something inside of it, u, and that u is being raised to a power. This very interesting property of log says that I can turn it into this. So someone tell me what happened. According to this property, what are you allowed to do? I took the power that was up here, right? That n. And where did it wind up? Out in front, right? And that's multiplication right there between the two. That's n. On the right side, it's n times log base bu. So that power dropped out in front of the log. All right? So on the left side, what we had was a power of n on the u. When we go through this property, it's n times the log. Power drops out front. All right, that's what happens. Last one, seventh property. And this one's kind of weird because it's not really like just an equation. Let me write it. If log base b of u equals log base b of v, then u equals v. So let's look at what this property is saying. It says if you have a log with a log base b with something inside of it, right, like u, and if that's equal to the same log base b but of something else v on the other side, then the u and the v have to be the same. In order for that to be an equation, for that equality to hold, the insides had to be exactly the same. All right? That kind of makes sense? Like for the left and right sides to match up, what's inside the logs has to match also. So we'll use all these properties now for the remainder of the class. I also want to point out to you on properties 4, 5, and 6 that the arrows I drew, you know, the arrows that go to the right, please understand that these properties work the other way also. So you could actually go, if you read this from right to left instead, the property number 4 says if you have two logs, right, with addition between them, you can make it a single log with multiplication inside. The second or fifth property says if you have two logs with subtraction between them, you can push it over to one log with division. The sixth property says if you have a number or something in front of a log, you can push that number up as a power. All right, so these go both directions. When we go from the right to left, we call that condensing. When we move and use those properties from left to right, we call that expanding. All right? Does this seem fair to you? All right, we're going to hit all these properties. It's going to be a long day of this stuff, so let's see how things go. Did I go too fast? Need to go back? We okay? Everyone's good? All right, here's an example. Let's solve this problem. Didn't we do that problem earlier? Something very similar to this? Now, how would you do this according to yesterday or last class? How would you do this? Or what did I say yesterday? Earlier today or last time? How would you solve for x here? You would do log base 4 on both sides, right? Now, so I'm going to write that on the side as far as what we have learned in the past, right? We would do this, correct? What would the left side become? X. And the right side, we'd have to do ln 8 over ln 4, right? Change of base formula. And then we figure that out on a calculator. That's the way I've shown you to do it. And there's nothing wrong with that, okay? Nothing at all. However, if we go back and we look at property 6, look at property 6. Property 6 says, I can't reach. Izzy, sorry to sneak up on you there. Sorry, girl. Okay, property 6 says that if we have something to a power, right, we can drop that power out front as long as there's a log sitting in front of it. And it doesn't matter what log, does it? I can have any base. That's what that says, right? Now, let's go back to the problem that we are looking at here and attack it a completely different way than last time. I'm not doing this to confuse you. I'm just doing it because there's more than one way, and this way I'm showing you might be more efficient. So I'm going to come in with a log on both sides, but I'm not going to force myself to do log base 4 anymore. I'm going to choose to use a log that's on my calculator, which is the natural log. That's the one that everyone has, right? ln. So what if instead of doing log base 4, I do natural log 4 to the, come on, Robert. I mean, I have taken natural log on both sides, haven't I? Okay. Now, property 6 says that if I have any log, right, any log, doesn't matter what it is, of something to a power, then what can I do with the power? Pull it out front, right? So I can actually take this x and drop it to the front of this right here. And what I would get is this, x times, now what's still here? ln 4 equals ln 8, right? Now how could you get x by itself? Divide by, because remember that's multiplication right here, right? So I would divide both sides by what? ln 4. So if I divide the left side by ln 4 and the right side by ln 4, then I'm left with x equals what? ln 8 over ln 4. Isn't that the same exact result that we got using log base 4? This turns out to be the more efficient way and the more preferred way to solve these sorts of equations. And so you may be sitting there going, I like what we did last time. I'm going to stick to what we have last time. Well, because you need to understand the idea of when you put log base 4 with 4 to the something, they kill each other off because they're inverses. That was the whole idea, is because they were inverse functions. But because of this very strange property of logs, we can totally get around that, having to have that property or have that inverse thing happen. Okay, does that kind of make sense? Now let me give you a problem that will force you to not be able to do what we did last time. Yes. Oh yeah, no, we get that on calculator. Natural log of 8 over natural log of 4, whatever that is. Okay, how about this? How about 5 raised to the 2x plus 1 equals 9 raised to the 3x. Now this is the first time we've seen a problem like this. What you should notice is that the x we're trying to solve for appears in the exponent, right? But it actually appears in two different pieces of the equation, on the left side and the right side, doesn't it? So let's say that I hadn't shown you the properties of logs from, today, and act like this was last class. If I gave you this problem, you would be saying, okay, well, I need to see what the base is, right? 5. And then I need to wipe out that 5, so I'd come in on both sides with what? Log base 5. But look at the right side. Your base is 9. So log base 5 is not going to wipe out log base 9. All it's going to do is create a major issue for you, because you're going to have log base 5 of 9 to a power. It's going to be weird, right? It won't go away. But watch what happens. That's not what I wanted. Watch what happens if I just say, forget it. I'm going to come in with natural log instead. Natural log will allow me to pull those powers down, won't it? Okay, so I'm going to come in with natural log on the left side. 5 to the 2x plus 1 equals natural log on the left side. And why am I using natural log again? Why? Yeah, that's the key that, eventually, like if I wind up with like natural log 7 or something like, I'm just going to be able to go to my calculator. I could have used any log on both sides, right? But the natural log is the one that I'll be able to go to this, and I won't ever need a change of base formula. I won't need it. So let's start pulling the exponents out. So I'm going to take the exponent, the entire thing, right? Drop it out front. The 3x and drop it out front. So I'm using that property 6. So here's what I get. The 2x plus 1 comes in front times natural log 5. Now technically, I need that 2x plus 1 to be in parentheses. Does that make sense? That you would need that? It's that whole thing times the natural log of 5. Equals, on the right side, the 3x comes out front times natural log 9. Y'all with me? It does not. The 3x does not have to be in parentheses. Why? Term. It's a single term. See, the 2x plus 1 is 2 terms, so that natural log 5 would have to distribute to both. 3x is one term, so it's just times the natural log 9. Now, in previous problems, we were able to just get the x by itself pretty easily at this point, right? But see, we have x on both sides. So here's what I recommend you do. Go ahead and figure out what natural log of 5 is on your calculator, and then natural log of 9. And they're going to be decimals, so go ahead and just give me a rounded 2 decimal places. I'm going to say 1.61 for natural log 5. And then the other one is what? 2.2? All right. 1.61 and 2.2 are just numbers, aren't they? I'm going to take those numbers. I'm going to distribute the 1.61 through this parentheses. And then on the other one, I'm going to just multiply 2.2 times 3, which will give me 6.6, right? Y'all still there? All right, what's 2 times 1.61? 3.22. So I have 3.22 what? X plus 1.61 equals 6.6x. See, what I've done is I got rid of the natural log 5s, turned them into decimals, and now I just have a linear equation in x. So that you just isolate x now, right? How do you want to get x by itself? Okay, so subtract 3.22x on both sides. So take your 6.6, subtract your 3.22. You should get 3.38x. And then on the left side, we still had 1.61, didn't we? Is everyone still following me? All right, divide now. Both sides by what? You're trying to get the x, right? So divide the 3.38 out of there. Take 1.61 and divide it by 3.38. And you get 0.476. Oh, I said round 2 decimal places, sorry. So 0.48 is x. What do you think? The key to this problem would be coming in with natural log on both sides, right? Remembering the parentheses on that thing there, right? Turning your natural log 5 natural log into natural log 5 and natural log of 9 into decimals, distributing through, and then solving the linear equation. You think you could handle that? I'm actually going to give you a homework assignment out of your book today. I know. I mean, you paid for the book. I may as well give you problems out of it, right? Yes.
I got lost on the very last step.
Which part?
Right
This?
after the 1.6 equals 3.38.
Oh, all you're doing is dividing 3.38 on both sides. Okay. That's good? All righty. Now, everything that we've done, like last class, the homework assignment, and then this problem here, these are all what we call exponential equations. They're equations where our variable is in the exponent, right? We are now going to look at logarithmic equations, which are going to be different. They're going to be equations where your x is inside of a log. But before I can do that, we need to mess around with those properties that I gave you just a second ago a little bit. So the whole, product turns into 2 logs, all that thing. Division turns into subtraction. Let's mess with those a little bit, and then we'll get into the solving log equations. It's fun, right? Okay, expanding. You know what? Let's do condensing first. Condensing log expressions. All right, I'm going to do this by examples. The instructions here, okay, are to condense. When you think condense, that should make you think like make things smaller, right? Less. Expand means, I guess, more, right? Condensing, less. So I would like for us to try and condense this. Log base 7x plus log base 7x minus 1. How many logs do you see? Notice there's no equation here, right? I'm not trying to solve anything. It's just an expression. 2 logs. What's the operation between the 2 logs? Addition. Also notice they both have the same base, right? For me to use that property, they both have to have the same base. So I can push these two into a single log, can't I? I'm gonna put equals, and then I'm gonna circle here a number 4. And that means I'm referring to property 4, right? Property 4 allows me to take this and turn it into a single log, right? 1 log. And inside of that, what? Those 2 multiplied, right? When I say those 2, I mean whatever's here is like my u, and then everything over here is like my v. So I marked them in red. U is the x, v is the x minus 1. Put those 2 together and multiply them. So x times x minus 1. And go ahead and multiply x times x minus 1. What do you get? X squared minus x. Just distribute it, right? Multiply it through. That's it. It's condensed. So how do you know it's condensed, right? That would be your next question to yourself. Like, how do I know I'm done? That's always the biggest question that students have when we get to these things. How do I know I'm done? Really what you're looking at is to have a single log if possible, and everything inside of it as simplified as possible. So that works. Right, I can't do anything else to x squared minus x. So I'm done. Ready for another one? You could do GCF, but you'd be back where you were before. Okay, how about this? Natural log x minus natural log x plus 1 plus natural log x squared. So how many logs do we have? 3 of them, right? We have subtraction between the first 2 and addition of the last one. Are they all the same logs with the same base? Yes, because they're all natural logs, right? So the way we're going to do this is we are going to do this the way we've always done addition and subtraction, from left to right, right? So I'm going to start by taking these 2 logs and condensing those 2. Now what happens when you have 2 logs with subtraction between them? It turns into what? By property 5, 2 logs with subtraction turns into division, but I want something else. 2 logs with subtraction becomes 1 log with division. Well, no, because this is a big mistake. Here's what people will write. Natural log x divided by natural log x plus 1. This is incorrect. You still have 2 logs, don't you? You have division, but you have 2 logs. That's not what you get with this property. This property says 2 logs with subtraction turns into single log with division inside of it. Okay, division inside of that single log. Major difference. This is your u, this is your v, so your u and your v were here. Does that make sense? All right, that's property 5. And then I'm going to take that other one, just tack it on to the end. I haven't done anything to this one yet. Now you almost like hit the reset button and start over. How many logs do you see? 2. What's the operation between them? Plus. So 2 logs with addition turns into 1 log with multiplication. Now my u and my v are different here. U is everything in there, my v is everything in there, right? So my new single log becomes natural log. I'll have that x over x plus 1, but then times what? X squared. And can I put those two together somehow? When you multiply that x over x plus 1 times x squared, where does that x squared go? Top or bottom? Top. And what's x times x squared? X cubed over x plus 1. I'm done because I have a single log and everything inside of it has been simplified. Can y'all see why they call it condensing though? You take this expression, which is pretty long and drawn out, and you turn it into a single log. One half log x, I don't know why it keeps doing that, x plus 2 minus 3 log x minus, stop man, log x squared minus 4. You know what, make it plus 4. X squared plus 4. I'm not quite ready to do that to you yet. You ready? How many logs do we have? 3. Are they all the same base? What's the base of all these logs? 10. These are all base 10. Why? Because it's not written down, right? If it's not written down, it's base 10. If it's ln, it's base e. And any other log, you have to write the base. So these are all base 10 logs. I have 3 of them. I have subtraction between them. So I know subtraction is going to become some sort of division. But notice that I have all these numbers out in front. You can't put these together if you have half in front and 3 in front. You can't put them together yet. So what we have to do is first resolve the issue of the numbers in front. And the last log doesn't have a number in front. I mean, there's a 1, but you don't need to write it. So how can I get rid of the 1/2 here? Well, I don't have an equation, so I can't do anything to both sides. There's nothing to work with. The 1/2 cannot distribute through. No, because this is not just like a normal parentheses. The log is a function, so you can't pass numbers through the function. It's a property, which, that's right. I'm going to use that property. It says, remember, if we have something out front, you can push it up here as the power. Now, we used it the other way around. We took the power and dropped it out front, didn't we? But now we're going to use it backwards. We're going to take the number, we're going to push it up as a power. We're going to do the same thing out here with the x. We're going to push it up here as a power. Ready? What property was that? I believe it was it 6 or 7? It was 6, right? Property 6. 4 was the addition. 5 was the division, 6 was the power dropout, and 7 was that equal, inside's equal. All right, so this is now going to become log. Whoa, hold on. What happened? What happened? What the heck happened? What does taking x to the x plus 2 and raising it to the 1/2 power mean? It means the square root. That means the square root of x plus 2. We've talked about this several times now. Anytime you raise something to the 1/2 power, it's the same as taking the square root. So when that 1/2 came up here and became my 1/2 up there, I was taking the x plus 2 and raising it to the 1/2, which meant take the square root of the whole thing. Does that make sense or not? So that's why that says log square root of x plus 2. Then the 3 went up, it became log x cubed, and I didn't do anything to the last one. Okay, now, in order from left to right, you do these two logs using property 5. 2 logs with subtraction between them becomes 1 log with division inside. Yeah, if you write 2 logs on the test, when you're trying to condense, if you were to write this instead, log square root of x plus 2 over log x cubed, that's a major mistake. I don't consider that a minor thing. That's a big deal. So that is no go here. Any questions on what I did get, though? All right, now what you'll do is look at these 2 logs, there's subtraction between them, and you will do again by property 5, make this a single log with division inside. What goes into the top? What goes to the top? All this stuff, right? Square root of x plus 2 over x cubed. That's going to be the top. So square root x plus 2 over x cubed. And what's the bottom? X squared plus 4. That goes on the bottom. Do you agree? Now on a test, that's going to get you 9 out of 10 points right there. Yeah, you can do something with this. Because when you really look at this, the bottom is really a fraction, isn't it? X squared plus 4 is the same as x squared plus 4 over 1. And a fraction divided by another fraction is the same as multiplication of the reciprocal. I know we've talked about this before. So this becomes log, and then what you would have is your top fraction, square root of x plus 2 over x cubed, times the reciprocal of the bottom, which is 1 over x squared plus 4. And then what you could do is you could take the x cubed on the bottom and distribute it through to each of those terms. And then on the top, take that, multiply it times 1. So multiply straight across, basically. And you get log square root x plus 2 over x to the 5th, good, plus 4x cubed. That's the final version right there. All right. I think that's enough condensing that I'm going to take you straight to solving equations now. The expanding is not as necessary in this class. We'll do it if we have time. Expanding would be basically me giving you this and asking you to go backwards. That would be expanding. So you would say, oh, okay, I see division, you split it into 2, and then so on and so forth. Kind of a pain in the butt. We don't need it to solve equations, though. So here we go. Solving. Please stop doing that. Log equations. So we'll start off pretty, well, let me start off by reminding you of something. Recall the loop. Y'all remember the loop? The loop was like this. If we had log base b of x equals y, we could say that using the loop, this turned into what? B raised to the y must equal x. Okay, y'all remember all that? Okay, we will use that to solve log equations. There's other ways to do it, but this is by far the easiest way to do it. By far. Example, solve this equation. 3 log base 2 of x minus 4 equals 2. All right, tell me if you can, before we even start this, what is inside the log? What is the... Okay, yeah, is it the x or the x minus 4? Is it just the x or the x minus 4? It looks like x minus 4, right? It's actually just the x. If I wanted x minus 4, I would have had to have written it that way. Okay, so the only thing in that log is the x. Okay, that's just a little thing on notation. The use of parentheses is vital when you're messing with log equations. So that's not what we have. So the only thing inside of the log right now is the x. I want to get that x outside of the log. Now, what did we do when x was up in an exponent? How did we get the x out of the exponent? We came in with natural log on both sides, right? When log is trapped inside, when x is trapped inside of a log, we don't do that. We use the loop. So there's 2 different types of equations, 2 different approaches, all right? So to do the loop, I look right now, and you can almost see the loop here. It's 2 like this, and then like that. But wait a minute, hold on. We can't do that because there's all that other crap there, right? We have a minus 4 there. We have a 3 in front of the log. What we need is kind of like before. We need to just have our log, our base, some junk, and some junk here. So then we can just apply the loop. But just the log by itself. So add the 4 first. Good. Very similar to what we did with the exponential equations. Add 4 to both sides. When we do that, we get 3 log base 2x equals what? 6. Now can we do the loop? Not yet. Divide both sides by 3. See, divide by 3, divide by 3. And now you have log base 2x equals what? 2. I had a dream I was involved in a murder. It was weird. I woke up. I mean, I woke up and it was weird. It was like I couldn't figure out. The police were talking to me, but I couldn't. I know that I stashed a body, but I don't remember how that all happened. I just knew that I was like, okay, did I leave? Did I get fingerprints on it? I was like all CSI, like trying to see if it's weird. Like I don't think I'm like crazy, like gonna hurt anyone, but it was very strange. It's like I knew I was guilty of something, but I didn't. It was a strange dream. I woke up, told my wife, I was like, I had a dream I murdered someone. And she's like, I had a dream that you shot someone in our backyard last night too. I was like, whoa, I don't know, something, this bad karma, Halloween karma's coming back. All right, sorry about that. Okay, get back to this. Divide both sides by 3, right? Any questions on that? On not. It was one of my neighbors. It's a weird dream, man. Okay, divide both sides by 3, and then what? Now I can do the loop. Good. I can do the loop now because I have a log by itself. So this should be turning into what? 2 raised to the 2 equals x. So that turns into 2 raised to the 2 equals x, which means x is what? X4. I'm done. That's probably too much information. Sorry about that, y'all. I'm going to have to edit this video now. You realize that. What was my time mark on that so I can go back easily? 55, 56, about 55 minutes into class. What do they call that when you incriminate? I incriminated myself there. I need to get rid of that evidence. Okay, next example. How about this? Negative 2.4 natural log 2x minus 1 plus 7.3 equals 5.7. All right, what type of equation is this? I agree. I mean, because your next test, you're going to have 2 types of equations, exponential equations and log equations. Exponential equations is when you come in with logs on both sides. Log equations when you use the loop. So which one is this? This is the loop, because you have a log, right? I mean, that's the key. And your x is inside of it, isn't it? I think I freaked Izzy out with that story too. All right. There's our x. See, our x is in our log, but notice now it's not just x, it's 2x, and not just 2x, it's 2x minus 1. So the set of parentheses tells you everything there is inside that log. Yes? Now the log itself, this whole piece needs to be isolated. So how about subtracting 7.3 from both sides? So we'll need a calculator because at some point we'll need a calculator, and maybe not right off the bat. So what's 5.7 take away 7.3? Negative 1.6. So I have negative 2.4 natural log 2x minus 1 equals negative 1.6. Now what? Divide by negative 2.4. So divide by negative 2.4, divide by negative 2.4, which leaves me with natural log 2x minus 1 equals 0.66. Oh man, that's 0.666. Man, it's just bad vibes here now. I'm going to say 0.67. Do 2/3? Yeah. All right. How about this? That all right? Do we have the log isolated? Can we do the loop now? Are you going to remember what the loop's going to be? How can you do the loop? There's no base there. What's the base of natural log? E. So even though it's not written here, and this is bad notation, it's really an E down here, and this is really log, right? That's really what natural log means, log base E. You have to remember that. I'm not going to tell you, hey, by the way, On the test, when you see natural log something and you're ready to do the loop, you'll have to remember that that means e raised to the 0.67 equals this. So e to the 0.67 equals what? 2x minus 1. And now you need your calculator. You need to do e to the 0.67. Round 2 decimals, I get about 1.95. 1.95 equals 2x minus 1. Yeah, this is a linear equation. Add 1 to both sides, divide by 2. $1.48. All right. So far, okay? I haven't used any of the properties with condensing and stuff yet, have I? So let's try and get one of those in before the end of class here. So one more. How about log x? We'll just say log x plus log x minus 4 equals 2. Right, the major difference between this problem and the one we did before, the two we did before, is that in this problem, the x we're trying to solve for appears in 2 separate logs, doesn't it? We have 2 logs instead of 1. So we cannot do a loop on 2 logs. You can only do a loop on 1 log. Well, it's okay because we know how to take 2 logs and make them 1, don't we? So we have 2 logs here with addition between them. On the left side, I can condense, can't I? So 2 logs with addition between them becomes 1 log with multiplication inside. All right, so I used the property 4. I'm just going to put that there. Property 4 from our properties from earlier today to get my left side condensed. Now can you use a loop? You have the log by itself, right? Well, yeah, we could distribute these through if you want. Okay, I'll go one more step. Log, we could go x squared minus 4x equals 2. But all that x squared minus 4x, it all lives inside the log, doesn't it? And the log is by itself, so I can loop it around now, but I need to know what I'm going to loop with. 10. The base is 10, right? If you don't write it, you write log, it's base 10. So this means base 10, so 10 raised to the 2 is this, right? 10 squared equals what? X squared minus 4x. That means 100 equals x squared minus 4x. And what type of equation is that?
My favorite.
That's right.
What is it?
Not linear. It's quadratic. It's quadratic. Move the x squared to the other side, or sorry, move the 100 to the other side by subtracting 100. And you now have a quadratic equation, right? Quadratic equation, which needs to be solved. I'm not done with this problem, but it needs to be solved using either factoring or quadratic formula. My guess is quadratic formula is going to be the only thing that works here. And you're going to get some weird decimal answers. All right? Can I borrow someone's book real quick? I have written the assignment down here, but I know for sure we're not ready to do this whole assignment, so I need to edit it a little bit. Can I borrow some? No one brought their book? Yeah, I wouldn't expect you to. I haven't used it in a few months. You do have it? Look at that. You have the ridiculous calculator, but you have your book. So you're prepared in some way that compensates for that calculator. By By the way, he did get a good one now, so he's okay. Jokes have to stop. They don't have to stop. They will, but they don't have to. All right, this was supposed to be page 462. So here's your homework for tonight. Page 462. Let's see. If you look at problems 103 through 109 odd, that's kind of like what I did in the beginning of class. So I'm kind of going in the order that I went today. All right. You do those. You'll come in with log on both sides, solve them like that. Okay. And then after that, we did some condensing, right? So those will be try 27 through 37 odd. And I'll put even next to this condensing. And then on these, it was solve exponential equations. And then we just started to try and solve some of these log equations. So 21 through 25 odd. Solve log equations. Do the loop, right? That's what happens here. And then I was only able to do one of these examples just now, so let me see, where the heck is it? Just try, and none of those are any good. I don't like this book. Yeah, ugh. Let's just do those. We'll pick up with like that last one where we had to condense. We'll pick up with that next time. Have a good weekend, everyone. Is it only Tuesday? Shit. Damn. I'm